Hi, for this recording, I'm going to show you how to solve the inequality absolute value of 2x minus 5 less than or equal to square root of x plus 5. Note that this similar example can be found in David Brandon's text, page 12, such as square root of 2x plus 3 greater than x. Alright, let's try to solve this inequality. So I have absolute value of 2x minus 5 less than or equal to square root of x plus 5. Note that because of the square root function, you know that this inequality is valid. This is valid only for x minus 5, x plus 5, greater than 0. X plus 5 greater than or equal to 0. Otherwise, we have trouble taking the square root. So, x must be greater than or equal to minus 5. Therefore, in the final adjustment, we have to take those into account if necessary. Now, since both the left-hand side and right-hand side are positive number, 2x minus 5 absolute value is positive or 0. Square root of x plus 5 is positive or 0. Therefore, we can square both sides. So, squaring both sides now, inequality still remains. Squaring both sides, as both terms are positive, so if and only if 2x minus 5 square less than or equal to square of square root of x plus 5, which is 5, x plus 5. And then absolute value of 2x minus 5 square is the same as 2x minus 5 square, which is 4x square minus 20x plus 25. This is because we know that absolute value of 2x minus 5 square is the same as 2x minus 5 square. As you square the function, you can do this. Now bring all the x to the left hand side, subtract all x to the left hand side, subtract x to both sides. Now they get minus 21x and minus 5 both sides get plus 20 less than equal to 0. Now continue with the factorization. Okay, so let's try an error. So we may want to try x minus 4, 4x minus 5. Let's try whether this works or not. So you have 4x minus 5. So minus 5x minus 16x to get minus 21x. Yes, this works here. So you factorize, right? You find that you have this inequality. Now to solve this inequality, the real number line is divided into 3 pieces. Right? The number are x equal to 4, x equal to 5 over 4. When you have 4x minus 5 equals 0 and x minus 4 equals 0. So you have 3 regions, x less than 5 over 4, x between 5 over 4 and 5 or 4, and x greater than 4. So you can take some test point. So for example, when x less than 5 over 4, example, x equal to 1. X between 5 over 4 and 4, for example, x equal to 2. X more than 4, for example, x equal to 5. Then you find that the product, right? The product, how do we know whether they are positive or negative? You can do a test point. So the product in this case is 4x minus 5, x minus 4. You find that the first term will be, when x equal to 1, it will be negative times negative. Second term also negative, so it's positive now. Whereas for x between 5 over 4 and 4, say x equal to 2, you get positive. 4x plus 5 is positive. 4x minus 5 is positive. X minus 2 is negative, so multiply, you get negative. And for x greater than 4, say x equal to 5. 4 times 5 minus 5 is positive. 5 minus 4 is positive, so this is positive here. And we are looking for inequality for 4x minus 5, x minus 4 less than or equal to 0. So we have this. Therefore, the solution is between, for this inequality, is in minus 5 over 4 to from 5 over 4 to 4, including 4 and 5 over 4, since they could be equal to 0. Now, taking into account that every number that x must be greater than minus 5 in the very beginning, x must be greater than or equal to minus 5. So, as our solution, x between 5 over 4 and 4 is very greater than minus 5, so no adjustment are needed, right? No adjustment needed now, because already the interval from 5 over 4 to 4 is very greater than minus 5. Therefore, the solution is x between greater than or equal to 5 over 4 and less than or equal to 4. Right? It's the solution. Okay, so this is the end of the solution.